We will now look at the basic ideas of differential equations. So a differential equation is one that involves an unknown function and its derivatives. And the solutions in the differential equation is a function rather than a number. So here are a few examples of differential equations. dy dx plus 8y equal to tangent of x, d squared y dx squared minus 12y equal to 0, and y prime of x equal to 7y squared plus 2y. The order of a differential equation is the highest order derivative that appears in the equation. So for example, my first and third examples here are going to be first order differential equations, while the middle one will be a second order differential equation. And any differential equation is called linear if the function y and its derivatives only appear to the first power and are not composed with other functions. And these are the ones that we'll particularly look at. Initial conditions specify the values of y and maybe its derivatives at a particular point. And if we have a differential equation along with the appropriate number of initial conditions, it's known as an initial value problem. So let's verify that this is the solution to the initial value problem. So we'll start by seeing if it fits this formula. So y prime of t will be equal to, we'll bring the 2 down and have 32 e to the 2t, and the derivative of 10 is 0. So we have y prime of t minus 2 times y of t should be equal to 20. So we'll see this is 32 e to the 2t minus 32 e to the 2t plus 20 is equal to 20. So 20 is equal to 20. So it does satisfy the differential equation. We also need to check that it satisfies the initial value. So y of 0 is 16 e to the 0 minus 10. Anything raised to the 0 power is 1, so this is 16 minus 10, which is 6. So it does also satisfy our initial value. Now let's find a general solution. So the easiest way to do this would be to take the integral. If we know the derivative is 3 plus e to the negative 2t, then the integral will be the actual function. So we have the integral of y prime of t dt equal to the integral of 3 plus e to the minus 2t dt. Like I said, the integral of a derivative is just the function itself. The integral of 3 will be 3t, and the integral of e to the negative 2t will be negative 1/2 e to the minus 2t plus c. So here's our general function. We'll do another one. This time I want to find the general solution of y double prime of x equal to x e to the x. So the integral of y double prime x dx will be equal to the integral of x e to the x. The integral of y double prime is just y prime of x. And over here, I'll have to do an integration by parts. So I'll let u be equal to x, and then dv equal to e to the x dx. This means du is equal to dx, and v is e to the x. So I have u times v minus the integral of v du. So y prime of x is equal to x e to the x minus e to the x plus c. In order to find the function y, we'll then integrate once more. So we now have the integral of x e to the x minus e to the x plus c dx. When we integrate the derivative, we just get y. The integral of x e to the x we actually just found to be x e to the x minus e to the x. The integral of negative e to the x will be minus e to the x. And the integral of c is cx. And since we took another integral, we'll have another constant of integration. So x e to the x minus 2e to the x plus cx plus d. Now let's try to solve an initial value problem. So y prime of t is 1 plus e to the t, and y of 0 is 4. So we'll integrate, like we did before. Y prime of t dt will be equal to the integral of 1 plus e to the t dt. So we get that y of t is equal to, the integral of 1 is t, and the integral of e to the t is e to the t, plus our constant c. And this is where the initial value comes in. I know that this thing should be equal to 4 when t is 0. So 0 plus e to the 0 plus c. E to the 0 is 1. And then subtracting 1 from both sides gives me that c is equal to 3. So my solution is y of t is equal to t plus e to the t plus 3. We'll do one more. So this time, the integral of y double prime of t, dt, should be equal to the integral of 12t minus 20t cubed dt. The integral of y double prime is y prime of t. The integral of 12t, we add 1 to the exponent and then divide by that number, so 6t squared, minus, adding 1 to the exponent gives me 4, dividing by that number, minus 5t to the 4th, plus c. We can now use the second initial condition to stick in and figure out what c is. So this thing should be equal to 0 when t is equal to 0. So we can see that this happens when c is 0. I'll now look at the integral of y prime of t, dt, which should be equal to the integral of 6t squared minus 5t to the 4th, and we know that c is 0. So I get that y of t is adding 1 to the exponent and then dividing by that number, 2t cubed minus t to the 5th plus d. And we'll now use the second initial condition. So this thing should be equal to 1 when t is 0. So we can see that d is equal to 1. So my actual answer, y of t, is 2t cubed minus t to the 5th plus 1.